Network models. In this video, we will discuss two network models that probably you already heard of: OSI model and TCP/IP model. And these two models are extremely important. They were created in the 80s in order to allow interoperability on the internet. Imagine that if you have a Linux server, you can only talk with the Linux computers. Or imagine if you have a Windows computer, you cannot send an email to an Apple computer. It will be a mess, right? What these network models allow us, the OSI model and the TCP/IP model allow us, is to have an interoperable internet. We don't even think of it, but every time you go to a website, maybe you are using a Linux computer with a Cisco router and the server is an Ubuntu machine with an IBM processor, and these things can talk together in a very seamless way. And this is what this OSI model and TCP/IP model give us nowadays, is internet interoperability. Now, the OSI model is not really that much used nowadays. The network model that won the network model battle was the TCP/IP model. But in this video, we will look at the differences. So let's get into it. Okay, so in this table here, you can see a comparison between the TCP/IP and the OSI models. So you have the TCP/IP here on the left and the OSI model on the right, and in the middle you have the protocols and services that use these different layers. You can see here that, for example, the application layer of the TCP/IP model is the same as the application plus presentation and session layers of the OSI model. And in this application layer, we have HTTP and HTTPS and FTTP, Telnet, NTP, DHCP, and ping, and also SSH, which is not here, but SSH is also part of this. So what is the OSI model? OSI stands for Open System Intercommunication, and it was developed in the 80s. So nowadays it's not that much used, but you still need to know it. The OSI model, as you can see here, consists of 7 layers, and each layer is connected to each other, to the other layer. The data moves down the OSI model, and each layer adds additional information. So the data moves down until it reaches the last layer of the OSI model. So you have data coming from the application layer to the physical layer, from the physical layer to the application layer. Now, as you can see here, the TCP/IP model is quite more simple to understand, and instead of 7 layers, it has only 4 layers. So what is the TCP/IP model? TCP model stands for Transmission Control Protocol, while IP stands for Internet Protocol. And this is widely used on the internet nowadays. And many times we don't even call it anymore TCP/IP, we just call it IPv4 and IPv6, but basically we are talking about the same. And we in this internet protocol TCP/IP, we have these 4 layers. So probably you have heard people talking, oh, this is layer 4. So when someone is saying that this is layer 4, it means that they are talking about the application layer, or layer 1 is the network layer, layer 2 is the internet layer, and layer 3 is the transport layer. And so as you can see here in the diagram, the TCP/IP model has these 4 layers, while the OSI model that we just saw have these 7 layers. And here on the diagram you can see what are the protocols and services that use the different layers. So on the application layer you have HTTP, and you basically have the applications and all that good stuff. The transport layer you have TCP and UDP, network IP, ARP, ICMP, and IGMP, and network interface Ethernet. And you can see here also in this diagram, so layer 4, application layer, again, the protocols used by the applications. Transport layer, layer 3, data channel between the applications and the internet. The layer 2 sends the data from the source network to the destination network, And then you have the network interface layer 1 that operates within the scope of your local network connection. So let's say your network interface, your layer 1 will be between your computer and your Wi-Fi network, for example. This is layer 1. And from your Wi-Fi network to the server of the whatever is a website you are talking with is the internet layer. And the channel between the application and the internet is the transport layer. And then when you are talking about application level is the application layer. Okay, now that you have talked about the differences between OSI and TCP/IP models, and we now understand that there is application layer, transport layer, network layer, and network interface layer, I want to talk about the transport layer. So as you can see here, we have mainly TCP and UDP as the transport layer, but I want to jump to this slide here, and you can see here TCP, UDP, and ICMP. I have added here ICMP because they basically use all the same network model, but they have different use cases. And let's look at them. So we have TCP. TCP is what we use for most of the internet use cases. Every time you navigate the internet, every time you send a file, most of the things, 99% of the things that we do over the internet is TCP. And that's why you call it TCP/IP and not TCP and UDP and ICMP over IP. But anyway, so TCP does most of the work over the internet, is connection oriented, meaning that you have a client and a server and they need to connect with each other and do a handshake. So when you have access to a website, you have you go to www.google.com and is going to retrieve the page from the server, and you are going to respond from your computer to the server saying, I got the connection, we are all good. And there is some digital signatures along the way. So TCP allows us to do this handshake and to have this connection between client and server, between your web browser and the server. And it's used for websites, emails, and many other things. Then we have UDP. UDP is what we say, it's a connectionless protocol. So you don't need to do this handshake. You can eventually send a file or send a package to someone else, and you just send it. You don't know if the other person is actually connected and if it received it. But you can send stuff, and it's usually considered a very fast protocol, and you can send lots of packages for general purpose. And then finally you have ICMP, the Internet Control Message Protocol, or ICMP. So it's entirely different when comparing to TCP and UDP. Unlike TCP and UDP, ICMP is not a traditional data packet protocol. ICMP is more a special type of packet used for internet device communication, carrying everything from redirecting instructions and timestamps, and allow the synchronization between devices, allow pings, and things like that. Alright, that's all for the network models. You need to understand the differences between OSI and TCP/IP, the different layers, understand what is the layer 1, 2, 3, and 4 of the TCP/IP model, and understand within the transport protocols what is TCP, UDP, and ICMP.